This question is from 2008 AMC 12B and it is problem 16. Let's get to it. A rectangular floor measures A by B feet where A and B are positive integers. So they already told us A and B are integers. So you may be thinking Diophantine equation or the equations with solutions only being integers. And when you only have integer solutions, you usually can factor something out to simplify what you have to do and figure out what's going on. So maybe the fact that A and B are integers is telling us maybe the factoring is going to be involved. And you may ask, why? How do you know that? Why is there a likely chance that factoring is going to happen? Let's say you have an equation AB is equal to 6 and A and B are integers. So Z being integer. Now looking at this, since A and B are factored, this is basically a factored form, A times B. And since 6 can be written as 1 times 6, 2 times 3, 6 times 1, 3 times 2, and obviously it also has negative counterparts, you can figure out all the solutions using this factored form. So if we can... So maybe factoring is going to be an idea, possibly. Let's go on. B is greater than A. So if we count a solution where B is less than A, you're overcounting. You're not counting the right solution. So this thing is a very significant information too. So, and as you can see, some answers are double each other, 1 and 2, 2 and 4. So maybe there's going to be some traps. If you miscount, you may double count and you're not going to get the right answer. So let's go on. An artist paints a rectangle on the floor with the size of the rectangle parallel to the size of the floor. So let's say this thing is a floor. And an artist comes by and he draws a rectangle. So he draws a random rectangle, and it turns out this rectangle, the unpainted part of the floor, forms a border with 1 foot around the painted rectangle. So, okay, so we know this thing is 1 foot, and this thing is 1 foot, this thing is 1, and this thing is 1. So that's 1, that's 1. So artist drew a rectangle such that the length of the gap between the rectangle that he drew and the rectangular floor is 1 foot on every single side. Okay, and what else do we know? And it occupies half of the area of the entire floor. So we know the area of this rectangle is half the area of the floor, and floor is A and B. The length of the floor is A and B. Those are the dimensions, where B is more than A. And you know area of the floor is A times B. So that's telling you the area of the floor, area of the painted rectangle is 1/2 of that. AB over 2 occupies half of it. And what else do we know? Is there another way of finding the area of a rectangle? Yes, there is. This length is B minus 2 because the entire length is B and you're taking away 1 foot and another foot. So that's B minus 2. And this length is A minus 2. So another way to write it is A minus 2 times B minus 2. Now let's simplify this a bit, see what we get. AB over 2 is equal to AB minus 2B minus 2B minus 2A plus 4. And let's continue. Let's move AB over 2 over to the other side. That gets us 0 on this side. And we have AB over 2 minus 2b minus 2a, and for the sake of it, let's move 4 over to the other side. So all the variables are on one side, the constants on the other side. And let's multiply by 2. The reason I'm multiplying by 2 is to simplify AB over 2 so we don't have any fractions. So negative 8 is equal to AB minus 4b minus 4a. And some of you, as soon as you look at this, you may say, let me think about this. Simon's favorite factoring trick, SFF. This is going to be Simon's favorite factoring trick. And if you don't know what Simon's favorite factoring trick is, that's more than fine. What it is when you have A and B multiplied together, when you have two variables multiplied together, and you have two linear terms of the variables added to it. So when you have A times B and you have plus A times something, in this case it's negative 4, plus B times something, in this case that's negative 4, you can factor this expression. And how do we factor it? Let me show you. So you know you have to get A, B somehow, so there has to be A on one side and B on the other side. Now if you think about foiling this expression, when you multiply this value by a, you want to get negative 4a. So this value has to be negative 4. And using the same logic, this value when multiplied by b should get you negative 4b. That should be negative 4. So this thing can kind of be factored as a minus 4 times b minus 4. But as you realize, this thing contains an additional plus 16, negative 4 times negative 4. So you have to do the same thing over to the other side. So we have 8 is equal to a minus 4 times b minus 4. Now what do we know about a minus 4 and b minus 4? We know b minus 4 is going to be greater than a minus 4. This thing is going to be larger. And the reason this thing is larger is because b is larger than a. So when you subtract 4 from both of them, b minus 4 is still going to be a greater one. So let's factor 8 into two things. So it can be 1 times 8. I'm not going to write 8 times 1 because b minus 4 is going to be 8. It's not going to be 1. It should be the one that's greater. So we only have to count 1 times 8 and 2 times 4, and that's about it. So we have one solution for 1 and 8. So a minus 4 being 1, b minus 4 being 8, and we have 2 and 4, a minus 4 being 2, b minus 4 being 4. So we have two solutions. We have two solutions to this. And which one has 2? The answer is B.